Okay, next, I am very pleased to introduce our speaker, Joshua Herman. Joshua Herman is an amateur data engineer who has been self-teaching various techniques with a particular focus on transformer architectures in relation to how they can be used in natural language processing, NLP. For his day job, he is a compliance engineer at Bank of America. Previously, Joshua worked as a software engineer and web developer. He has 10 years of experience in software development and engineering. He graduated from UIC with a Bachelor's of Science in the Engineering College. And then also want to give a shout out for our host, Tigis. Here's Michelangelo.
Hey, everybody. I'm Michelangelo. Welcome to Tigis. We are we build a financial research platform for financial investors. So in particular, a ton of text data, think like SEC filings and earnings and events call transcripts and things like that help financial investors research companies they might want to invest in. We use a ton of Python on the engineering side, but also I run machine learning. And so we do a lot in the PyData ecosystem and also LLMs. So super excited for the talk. And welcome. If you need anything, I'll be here.
So this is going to be an interesting talk. This project has been talked about at 3 places. Basically, I redid one. The original one was in Vegas for DEF CON 31. Was a demo lab where it would be like a 20-minute demo. It keep on repeating itself over a 2-hour period. The strange things about it was that I was able to actually introduce myself to new features that I didn't know about. Unfortunately, the system is down because of doing some upgrades by adding a few video cards to my home lab. I have a home lab as the hosting because Amazon charged me $700 once because I didn't shut something off. So I do my self-hosting, although I should also probably have a backup system in AWS. So what it means by a natural language network scanner is that you put natural language inputs and then a large language model will interpret it and use specified tools or attempt to answer the question. It's really an agent-based system called a zero-shot React system. You can see similar things in GPT-4 when you add tools like Wolfram. So a little bit more expansive of who am I? Already been introduced to. I also would like to thank the PyData host because I forgot my laptop, which had me sort of redo this presentation by going to the Apple Store on my phone. You can find the code for this software here. It's called Securday. You may find it on the DEF CON website called Saturday, and since there's too many name collisions, I renamed it to Securday because that's not found. And I was able to register that domain. I can be found at Zirabigugang on Twitter, Discord, and Reddit. Don't ask why I chose that. And it's open source. It's on GitHub. As I stated before, this is what it looks like. It's in the Apache 2 license. A few people have started. The project is really more of a prototypal stage. You'll have to, very complex to set up. And I haven't set up like a Docker image or, I have okay directions, but it's very involved setup due to its architecture that will go later. But I think it would be more interesting now to show off like what it does. And so like example usage, with all these large language models, also Securday is also intended to have not only a web interface, which a lot of people are thinking of, but also a SMS interface, which can also be able to be used basically anonymously, as long as you could get a cell phone. So this is a negative, or this is a use of it through SMS. Like, what is the IPv address of defcon.peg? Does not, host name does not resolve to an IPv4 address, mainly because .peg is a TLD that doesn't resolve. And two, if that TLD did resolve, the host name, defcon.peg, would have to be registered. So really, this is a complex set of actions. It reads the input, reasons about it, and writes the output. And this is an inference mode, conversational and zero shot action, meaning it's looking at the tool descriptions. And this is using the bash tool, which they renamed to shell tool in LangChain. And then it probably usually either uses curl traceroute or to do that. And then this is another thing where it's interpreting the input and the output and using tools. I've seen it use either ping or traceroute or dig. I'm not, due to the state of the upper LLM, there are unpredictabilities on how it inputs and outputs data. Also OpenAI changes the LLM almost constantly now. Like, they have much higher context windows. There's a lot of rumors, and they don't really publicize how even the GPT-3 that they have. The GPT-3 in their archive paper is a 175 billion parameter model, but now they have this thing called GPT-3 Turbo, and that's not publicized at all. Either is like GPT-4 Turbo. Like, we only have rumors about what GPT-4 uses or is. It's like, it could be like around maybe 300 billion or 3 figures billion parameter models that are all reading the input. That's one rumor, but there's nothing definitive. This is more reasoning. So this uses you'd think it either uses NMAP or it can use Shodan. For this, it actually uses Shodan, but it also explains to you what it does. So after the port scan, it then reasons about what does that information mean? Because usually in a port scan, the NMM output would be 53 DNS. But here it's saying port 80 is used for HTTP, which is the foundational of data saying on the web. So it's reasoning, not so you can see the levels of reasoning on what's being done. You find that giving more information about how to use the system makes it more instructive, but because it's sort of like clicking the button of like do something random on google.com, or the LLM interface isn't really it's not really intuitive how to use it, number one. And number two, I start to record what I've actually successfully used it for when it does something unintended, like I've seen it do actually language translations of this. Like, I can write the above in German and it'll output back into German and everything else, or Spanish. It doesn't work for pictograph languages like Chinese, I think. But yeah. And then this is Cloudflare just doing IPv6, very similar with what we've seen. But this time it actually did spell check. So Cloudflare.com did spell check and did what I meant and do Cloudflare.com, which is more emergent behavior. I would say the most interesting thing about the system is that emergent behavior does exist. with us with a limited set of tools and zero-shot react agents. Or this is sort of when Shodan doesn't tell you this. I think if you pay for a higher tier of Shodan, it may tell you this, but I don't think so. Or shouldn't? Yeah. I think Shodan doesn't allow you to do this, or it does, but you have to, if it does, I think you have to pay a lot more. And if you use an mmap, that's not very friendly. And then here's like, it's using trace path. This is a little bit hard to read, but it's basically trace pathing my machine. So this is more instructive, and I did censor stuff out. This is like more like when you host these applications, you also have to do a good security model. You have to consider if the output into an agent will reveal information about that person. Also, I don't use Comcast anymore, so it's not that bad, but these LLMs, since they have behavior that is undefined or can't be totally boxed, because this is a higher level of security flaws that are not really understood that well, because we haven't seen LLMs for a long time. Then it can do some basic stuff. This is usually Python. It probably wrote a Python script for this. This is the creation of a bash, arbitrary bash scripts. You can also have it execute the bash scripts too. Then this is a thing I added recently. So this is a malware detector system. So there's this website called VirusTotal that has an API where it can scan the URL and then tell you how well it's if it's malware. And the URL I have is the malware test file. If you want, you can download the malware test file, and then your Windows 10 installation may or may not trigger it. I don't use Windows, but yeah, it should show up as malware by some scanner. Also added, this is another tool I added since DEF CON, which is telephone lookup abilities. So it's tells you where it is, when it is, how risky the fraud, and so forth, and how it was registered as a VoIP number. This is I did have a video of the website, so I do have, it's a little bit small. You can see it trying to, it says like the IP address 1.1.1 where its location is, and then what ports are open on 1.1.1 in German, and then it'll put the output in German. Used a tool called, used a web tool for this that I'll expand upon. It's in the architecture part, and it'll do like, so it has a basic interface that the SMS tool is. It's one result. It's not chaining results. It's like a Google style interface. As you can see, it does have on the top, uses a, yeah, so this is basically wrapping the system in Streamlit. And Streamlit is a declarative way to make a simple website for your machine learning models. It's all in Python, and then it just generates the interface. So now that we've shown you what the magic it does, we can go more into what's happening. So we can start with the implementation. So this is the output, what you'll see in the system when it's doing the inference system with GPT-4. And after it's it pops off of a RabbitMQ query. Then it just tries to interface, then it resolves it, resolves the chain, and then outputs the thought. So here, either an incoming SMS comes in from Twilio to Flask. Flask and Twilio can communicate with each other using HTTP. I use ngrok to just give me a addressable IP address. And then Flask just basically uses an HTTP style of interaction with Twilio. And so it sends and receives first you have an incoming SMS, it's interpreted by Flask, and then I do a push onto RabbitMQ. What was happening was I had a problem with Twilio not being able to resolve the output because it was just taking too long and Twilio was timing out. So I used RabbitMQ and used Twilio twice. The first time I used Twilio, I would receive a message, and the second time, after the LangChain is out, LangChain is done, I send the SMS back. Then this is bypassed by Streamlit to do like a push query to LangChain, and then OpenAI works with the tools, and then relays back. So you can go from Flask to the push query under RabbitMQ. RabbitMQ then, if the queue is not empty, pops up the first query. It looks at all the workers. The workers will start the inference into LangChain, and then LangChain and OpenAI go back and forth. So LangChain will take the input. It will then use the descriptions of these tools: Wolfram Alpha, Shodan, Bash, Python, reverse total, verse phone, virus total, IP quality score, and census. So how a zero-shot reaction system works is you have descriptions of tools. So then GPT-4 or whatever LLM you use will take those descriptions of tools and attempt to apply them and see if it gets a satisfactory answer. And once it does, OpenAI will return back to you the final product and then relays back to you either Streamlit. The Streamlit way, it just pauses until it's gotten back from LangChain because of the way that Streamlit is designed. It doesn't need this RabbitMQ. The whole RabbitMQ part of this is only for the problems that I had with HTTP requests taking too long in Flask. But Streamlit doesn't need that. So for example, for Bash, I say is already known because there is a shell tool predefined. You can define your own tool really quickly, such as virus total. I just say it's a very simple. It's just a method, and you have to do two things. You have the method call, which is very simple, and it's like a requests. It uses requests, and the description. So the tools are just one method and one description, and then it can reason about the inputs, and then it does that. This is Bash reasoning that it needs to use ping because I needs to ping google.com. And then it computes the final answer. When it has final answer, that's the stuff that is sent back to you. as you can see at the top, it says, I need to use a shell command to ping google.com, meaning the first query was most likely, what is the latency to be anything from latency to google.com or directly asking it to do ping google.com. But what this is, if it says I need to use a shell command, that's most likely it reasoning that it needs to use ping, which is predefined in, they used to call it the bash tool, but now they call it the shell tool, which is more accurate. But it's also the shell tool and the Python tool are the most, two of the most tools that have the biggest impact in how they can mess up your system, like just do rf/. Don't recommend that. Dockerizing the system would help, but then it could still wipe itself. So it could be, there are ways you could mitigate it, like just running the bash script into some kind of like actual, like it would just execute itself in a VM. So if it deleted itself, you could just spin up a new one. So let's go into the theory. This was sort of lacking in my previous presentations. I wanted to add this. So we've been, the progression from to transformers, it's been a long time. Bag of words, basically words, bag of words, we're changing how we interpret the vectors in two transformers, the creation of attention, why we need RNNs or even LSTMs, which why though, well, bidirectional STMs, they all had limitations that we had to push past to get the transformers. Transformers needed an attention mechanism, but we figured out that it didn't necessarily need the feed forward parts. The bidirectional LSTMs and LSTM models tried to address the fact that language-based inputs are left to right, they're not squares, and RNNs were more basic in that they didn't have enough, had memory problems, and then word invention bag of words. The left picture is probably the most famous picture when we do transformers. I would say nearly everybody who's looked at the transformers picture uses it. Even the I would recommend reading through the illustrated transformer if you want to know more about this. Then there's like an LSTN here on the right, and on the bottom is the basic classification tax of a neural network. So this is a vastly simplified training of a artificial neural network. On the left, we have inputs. On the right, we have classes. And in the middle is the training of the system, or is the neural network. So as inputs, we have a water, a shell, and a starfish. And then the reasoning of what everything is being trained in the middle. And then the output is the classifications, or the things that it wants to classify, the starfish and this annulus or circle. So on the right so we have the data, we have the model in the middle, and then we have the classes. That's another thing that deep learning systems can do. While there's a lot of talk about generalized or generative AI that's important, classification is very important too, and it's not nearly as stressed in transformers in general. such as you can use it like to classify programs or to classify if a program has a security flaw, like for example, memory leak, like a cross-site scripting leak and so forth. DARPA has at DEF CON 31, DARPA has a LLM-based supply chain competition that's going to be in 2025. It's a 3-year system where they're doing an AI-based competition. They capture the flag to solve them. They want to have 25 languages, and whether you have to reason on if a system has like supply chain attacks for security issues. And also the stranger part is that half of them though will be C and C++ security issues, but it will be not as emphasized. So half will be like 20 languages like Rust and so forth, like obscure, a little bit more obscure languages, and maybe more scripting like Python, but C and C++ is obviously heavily emphasized due to the hardness of creating memory safe systems and other attacks, and the prevalence of C and C as languages in general. And here is the execution of that previous classifier, where it's classifying it into the based on we see the starfishes are classified. Some of the starfishes are classified in one or the other, and the dots and so forth. This is more of a left to right LSTM, where this doesn't have attention. Well, this is where they started doing attention, but it used sequences in an RNN to do like a projection to do machine level translation. That was the first time this was done, was actually, I believe, the upgrade to Google Translate, where it could use RNNs with seek to seek models. And finally, transformers have like an input and output embeddings, but those are like just translating them into numbers, tokenized numbers, and then it does two things. It has a multi-headed attention in the input and the output with feed-forward neural networks in the end. So it'll do the multi-headed attention, addition and normalization, which is normalizing it and so forth. So questions? So the question is, if you want to host your own LLM model, is it expensive? By host, what do you mean by host? You mean host it on your own hardware or the cloud, or? That depends on how many parameters you want. So for me, if I want to host like Code Llama or a derivative of that with 34 billion parameters, you can do that with a Threadripper you can do that with a MacBook. You can do that with a Threadripper with 128 gigabytes of RAM. But the main thing that self-hosting it is memory size. So the better question is, how many parameters do you want, and there's this thing called quantization, which is what will I tolerate because with quantization or picking smaller parameter models such as Llama 7B, or Llama 2 like 7B, you can host that on, I would say that most people's laptops could host that here. If you start hitting like the 34 billion parameter models, that's around, I believe, 80 gigabytes. But the smaller parameter models will have issues, mainly in the accuracy, because so quantization is so there's 8-bit, there's FP16 and FP32. So FP32 is most likely like what was the model, the original model. And then you need the parameter size. So it really depends on which ones you can tolerate. So GPT-2, most, I would say everybody could host it. That can be hosted on a phone too. I believe Llama 1 and 2, the smaller parameter models, can be hosted on a phone. But yeah, as you create, but you also quantize them, meaning you decrease so let's go back here. This will be a good slide to actually do it. So the actual weights in the middle, they can be floating points or not floating points or bits. So we're like truncating it or like we're decreasing the amount of bits. Like FP32 is a floating point 32-bit number, but a 4 or 8-bit number that can half all the parameters. So it makes it it can make it sort of less accurate and make it easy to host it on less memory. So it's sort of like weight. So yeah, it depends. Yeah, at full accuracy without quantization or without, if you want full accuracy without quantization, yeah, you need 40 gigabytes of VRAM. But that's also constrained in time. With quantization, you might be able to get it hosted on your computer, but it will take a longer amount of time to do the inference. So you just have to wait longer. But yeah, certain models can only be done in VRAM. You have to convert them. We'll still have to download the weights. It'll still be like a 40 gigabyte download or something. Then there's these tools. So Llama CPP has some tooling, or there's a lot of tool, and others have some tooling where you can quantize them to make them usable for you. But you're giving up something. You're giving up speed or accuracy, most likely speed and or accuracy. Some of them, so LangChain, Wolfram Alpha, Bash, Python were coded by LangChain, or shell tools were coded into LangChain, but Wolfram Alpha still needs an API key. I coded Shodan, reversed phone, virus total, IP quality score, and census. It's just very easy, simple. Once you see the API definition, or even like the JSON definition, it's just a request in the tool name and a description. It's like, again, yeah. I'll get to that after this. So like here is Showdown. Oh. So there's two things. This is just using the virus Tolo client, which is their Python library. And then it passes a URL. And then I return text. Then here's the description I described. That's really it. Yeah. Anyone else have questions? The answer was, how could I do the output in JSON? I'm not totally sure how that could be done in LangChain, but you might be able to do that either with a prompt. Would say either, hey, LangChain usually has like output LLMs, but maybe you could take the text and reinterpret it or do something else with the tools. I've never done that, but there's probably some hack or even just, there's probably an API to do that. You'll probably have to mess with like the agent. I think if you traded a custom agent, you could probably achieve that, or look into the LangChain API. I've never done that. This is not Bank of associated with where I work at all. This was a hobby. Just want to clarify that Bank of America. This is not representative of Bank of America at all. But that's just what I do as a day job. Well, the first part I did mention, I don't know totally its limitations are, but on the other hand, I mean, if you asked it to like can synthesize programs, you can just bash scripts, but you can't do like you can't do certain things like maybe after a put scans, like I don't think it's not designed to do multi-step yet. I've thought of doing that. Right now you can't do multi-stage, or even you can't do like if you've used chat.openai, there's no notebook system. You can't reason about its previous state. It's just so going back to what I said about zero shot agent, what that means is a zero shot or like a YOLO or one shot, meaning one request reasons about it. And that's it. It doesn't have any state in between. You can introduce memory. I haven't done that. Or what I really should introduce though is caching, because the requests can become expensive. The way this got a lot more popular, but caching would be something. But yeah, so it can't do multi-level reasoning. I'm using the wrong agent. And that's like currently experimental, I would say, for transformers. Even OpenAI and there's rumor, nearly all research teams are trying to figure out the next step. The step after transformers would be like systems that do general reasoning and that scale linearly. The rise of transformers is really big because as we've been able to create these higher parameter models, or even better trained ones, they scale linearly with like the data sets we have. Like it's weird that maybe 20 years ago, we thought that like high, truly intelligent, well, not intelligent, that machines that would reason about this would either have a semantic end, meaning using like ontologies, or would be like created by a brain scan or some others thing. But I think Kurzweil had that prediction too. But instead, it's sort of like how does an airplane fly? An airplane doesn't fly by flapping its wings. Same with LLMs. LLMs don't talk by flapping their wings. They ingest a bunch of data straight from Reddit, which, when you think about it, really is like the subreddit male fashion device has a lot of questions and answers. The other interesting thing is all of them are rated by humans with very high and accurate human output. Like that was one of the reasons why that's one of the reasons why Reddit was rumored to increase their API prices, because if like one time Reddit goes down and Google search goes go bad, the other time is OpenAI is actively scraping that site, getting all these nice question answers that have been done by humans for free. So like these really high quality results, you just need terabytes of social networks, bunch of people that played video games until we figured out that they could be used by general purpose GPUs, which was 10 years ago, doing classifications of pictures, which have one of the big reasons why picture classification was done 10 years ago really quickly by general purpose GPUs they have a notion of closeness of the pictures, like a picture and a piece of text. Piece of text needs attention because this order of tokens in the sequence don't necessarily are one-to-one. But pictures sort of have a notion of closeness that's easy to compute because it's a bunch of 3D tense. It's a 3D. It's a 2D object, like a 2D matrix with all elements as like RGB. So, with all color photos. But since you have that closeness, I believe that's why the 2D classification worked very well. But we had to get attention to get for language to understand, because languages makes a huge very long tensor or long tensor, and transformers allowed us to have a sense of closeness. Any other questions? Nothing. The question is there anything stopping people from doing nefarious things such as looking at SSH keys? The answer is nothing. Before I said, like, yeah, Bash, the Bash tool and the Python tool are very dangerous. And yeah, but I didn't care that. I don't care that much. You could wipe my machine, but I do have backups. They actually tell you that, well, it's sort of obvious, but they do tell you in the documentation that these are the most dangerous tools. Like the best thing you would do is either make a user that has no permissions but can execute certain tools, but then they can't do root things. So, but yeah. You say that again? It can. Big thing is though, well, right now the system is off because I had doing some upgrades, putting GPUs in to do some local training. But regardless, the question is like, if I put a paragraph in, can it reason it? The answer is how long the paragraph is in, because the GPT-4 API has a context window. I believe it's 12,000 tokens or something. While it might take a long time, it might also time out, might not understand. So yeah, because when you're submitting this, what happens is in the back end, it does the tool description of the prompt, the tool description, and then reasoning. And if you exceed the context limit, basically LangChain will throw an exception saying, well, GPT-4 said context window. GPT-4 said the context window was too high. So yeah, that's a good question. That there are context windows to these APIs and or design, and if you try to exceed them, they'll just they'll just send you a failed request error. You say that again? Well, as I said before, it's not memorizing, it's a zero shot. So it doesn't have memory. Yeah. So transformers have no memory unless you tell them to have for them or not. You can do so. And LangChain does have abilities to do that, such as like vector stores and or so forth, or give it memory, like simple memory. But yeah, it depends. Its mine system is zero shot, and zero shot doesn't have independent memory between queries. Yeah, also you can't break down a multi-paragraph query like you said if you were using it. It would be better if to actually process that paragraph, either you'd use you'd probably have to do maybe tree of thoughts well, no, it wouldn't. It depends on what the paragraph would say and how to do it. Like if your paragraph was a set of instructions or independent things to do, it could break it apart, but you'd have to add like a shell, either a tool on top of that to try, or something else. It really depends on what the paragraph would be about. Any other questions? Thanks. Thank PyData Chicago for hosting me, and thanks everyone.